All right, we're back. In our last video, we got started on abstract classes, and we coded this class hierarchy. The most notable thing here is that animal is abstract. It may be hard to tell, but the text here is italicized. That's how we indicate that something is abstract on a class diagram. That's what this ultimately is, right? We see multiple classes, but we also see the relationship. This is saying that dog extends animal, bird extends animal. Not only is animal the entire class abstract, but the move method is abstract. What we learned in our last video is that the moment that you have an abstract method, the entire class needs to be declared as abstract. Now, what is an abstract method? An abstract method, simply put, is just a method without a body, okay? And the reason you would want this is because think about animal. The move method there doesn't really have a good implementation anyway, right? It's hard to answer the question on the previous slide, like what do you define an animal? What does the implementation of the move method look like? It's hard to answer this question because the answer is there shouldn't be one, right? There just really shouldn't be, because there's nothing that you can put in the move method in animal that would make sense for all animals. So why put anything at all? Equally, on that level, right? In my program, I'll never actually make an animal. It is literally abstract. It's an abstract concept. It's more of a category than it is anything else. So this starts to beg the question, why even go to these links? Why even have these things? So what we ended up doing is that we made a collection, an array list of animal. This is possible because these animals, where'd my slides go? These animals have a common ancestor, right? Dog and bird have a common ancestor of animal. What that means, and we could easily add to this class hierarchy, but what that means is I can create a data structure. Here it's an array list. It could be an array. There's plenty more other data structures. I can create a data structure, a collection, using that common ancestor, and I can add anything that is an instance of animal, right? Anything that is an instance of animal, such as bird. Bird is an instance of animal. I would get true if I were to run this. Dog is an instance of animal. Here it's referring to the variables here, right? I'm asking, is dog an instance of animal? What I'm really asking is the runtime data type the data type of the object equal to or beneath animal in the class hierarchy? Is dog equal to or beneath animal in the class hierarchy? Yes, that is an instance of animal. Things that wouldn't be instances of animal or anything outside the class hierarchy. String, scanner. Object is not an instance of animal because technically above this, object is above animal, so it's not equal to or beneath. So because these things have a common ancestor, they can go into the same data structure. And the reason why you want to do that is that maybe you want them to interact together, in this case, in a zoo, right? I've given you the game object scenario where you have elements in your video game that likely have a common ancestor. That way they can interact in the same world together. We can check to see, is your hero near any enemies? The only way I can basically do that is if they exist in the same data structure. They exist in the same world. And in order to get them in the same world, they have to have a common ancestor. That's the same thing here with animal. I want these things to ultimately go into the same collection. So that's why they even have a parent class. This is ultimately abstract because there's no good implementation for the move method. Whenever I have an abstract method, the whole thing needs to be abstract. And it's a good thing that it's abstract because I don't actually want to make any animals. We're actually going to talk about today. We hinted at it in our last video, but you can't make an animal as a result. So there's no good implementation for the move method, but I still want the signature. I still want to basically have a header in my animal class. Why? Because ultimately, this is going to be the compile time data type, right? Here, dog and bird, I'm adding the variables. It works because they are instances of animal. But when we're talking about instance of, we're talking about the runtime data type. When I'm looping through the zoo, which is the array list of animals, The compile time data type is animal. Why is that important? Well, the compile time tells me what I can call. All right, I'm going to say this and I'll say it again and probably one more time after that. The compile time data type dictates what we can call. The runtime data type, the data type of the object, dictates what will be called. Okay, I'm going to say it again. The compile time data type dictates what we can call. In this case, I can call animal methods. Another word for compile time data type is, I would say, the data type of the variable. In this case, the variable I'm talking about is animal. So its compile time data type is animal. So it can only call animal stuff. That is the move method, most importantly, right? Because this signature exists here, it means I can call move without having to convert this using casting. Okay, that is super sleek. It is intuitive because all animals move in our scenario. Shut up, biology nerds. So we can call the move method. We can call toString. There's really not much that we added to our animal that's unique to animal. A lot of this other stuff is coming from object, right? It was inherited. Animal technically has it because it inherited it from object, which is why we can call it here. However, as we saw in our last video, when I actually do call something like the move method, the runtime data type dictates which version will be called. Right? Hey, dog is an instance of animal because it says true there. Now, my zoo contains a dog and a bird. I know we're zooing on a budget here. It's a starter zoo. Give me some credit. But that first element, the runtime data type, is dog. So whenever I'm iterating over this zoo and I'm on that first element, I can call the move method because animal defines a signature. However, when it is actually called at runtime, the runtime data type dictates what version will be called. In this case, this is dog's move method, right? Run on all fours. When I go to the next element, which is a bird, the runtime data type is bird. I can call the move method because animal has a move method. However, when I actually do it at runtime, we call bird's move method, right? This is the polymorphism coming through, tying in with our abstract classes. Polymorphism is what allows us to even add this to this array list because these things are instances of animal. Also, polymorphism is whenever we, actually call this. Whenever I actually call the method, the runtime data type is dictating which version will be called. That is also polymorphism. I can't tell you what polymorphism is. I can show it to you, and man, this is it. Okay, think about this maybe with our game object thing. You are going through all the elements in your game world, and you're telling them to move, right? The enemy is going to move using AI, likely, in your computer game, in your game world. The human is likely going to maybe take in a user input or check to see what the user input is at that moment and then move based on that. They move differently, but they both can move. Pretty sweet. Okay, so we're going to kind of pick up there with a slide. I'll use this one. Oh, I already got it open. We saw a little bit of this yesterday. It says any class that extends an abstract class must override the abstract methods defined in the superclass, right? When we came in with dog and we said it extends animal, this got really mad at us. For one thing, it was constructor related, but the other, we have to give move a body or an implementation. Same thing with bird. Bird came in, extended animal. We had to give move an implementation. The reason being is if it doesn't have an implementation, right? If dog doesn't have a move, well, whenever I'm on dog and I tell it to move, that kind of breaks the program. This is a little bit different than a do nothing method, right? I would say that this method doesn't do anything. This method is literally doesn't do anything. When you go to execute it, it doesn't do anything. But if you look at this one, it is abstract, and we have the semicolon here. That's like worse than not doing anything. I don't know. It's the difference between like void and null. I don't know. So you have to give it an implementation. If you're going to extend a class that has an abstract method, you have to implement all of the abstract methods. Okay. In our case, we only have one. But what if animal had a eat method, for instance? I'm going to plug that in, and we'll see how this breaks things. Right? Maybe there's eat, and dogs and birds eat differently. Two related problems. I'm going to flip over to bird. It is now mad at me. What does this say? Class bird must either be declared as abstract, we'll talk about that in just a second, or implement the abstract method eat. Even though I'm doing the move method, I still need to do eat. Okay, so we need to implement all of the abstract methods whenever we do the extending. But there's a second option here that I want to talk about. Or be declared abstract as well. Okay. When would you see this? All right, let's make sense of it first. Tucked away here, I've got some intermediate classes. They don't have anything in them, and I don't really plan on putting anything in them. Maybe a constructor. But we have animals, and then, of course, we have the animal kingdoms. Maybe I want to make like a category in between. You have to forgive me here. I am once again asking for your forgiveness. Can I just copy and paste this? Oh, come on. Can I just draw a new one? Watch as one man jumps from one class diagram creating program to another. Oh, just let me copy and paste. Copy. This diagram is not valid to paste the content. Blah, 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 blah. Yeah, that. Yeah. That's not quite what I want. Do I have other options? We'll go with this for now. I'll figure this up off stream. But let's say that we're bringing in mammal as an intermediate category. And of course, we could have other things underneath mammals. You know, cats. That's it, right? That's all the mammals. I'm done with mammals. You have to forget. I used this tool like years ago to create this initially, and I have not touched it in years, which is why I have arrows, but don't know what I did in order to create them. So I'm going to tack on mammal and aves, which the Google tells me is the class that birds are in. Birds are not mammals. Don't at me, biology nerds. At me if you know how to turn these things into proper little arrows. So let's add these two things, these two classes, to our class hierarchy. I want to right click on the SRC, make a new Java class. I'm going to call that mammal. And I'm going to say mammal extends animal. It's going to be mad at us. And if we scroll over, it's going to give us the same message we've seen a bunch now. Class mammal must either be declared abstract or implement the abstract method move in animal. Okay, we saw why we would want to implement the abstract method move. That's what dog and bird did because they have a good idea of how they're going to move. But this other option also makes sense sometimes. Why? Well, think about what I said earlier about animal. In my program, I'm not going to create an animal. I'm never going to create an animal. It is more of a category than anything else. It is an abstract concept. The same is really true about mammal. It is also a category, right? So I'm not going to do that. I'm not going to implement a move. There's no move here, in my opinion, that would satisfy for all mammals, right? Aren't whales mammals? Okay, so what we can do, if we can decide, no, this class should be abstract, it is not going to implement the move. What we're going to do instead is pass along that priority to something else. Mammal's going to say, I'm not interested in overriding the move method. I'm just going to be abstract, and it's up to my subclasses to override the method. So we're just going to tack on abstract here. Now this is mad at us for a different reason, which is the no arg constructor, right? It says no default constructor. So mammal, as it stands right now, even though it is abstract, it could have a mix of concrete elements, right? We could come up with some instance variable, right? Private, Boolean, warm-blooded or something. I don't know. But right now we're trying to call a no args constructor. So what I'm going to do is create a mammal constructor. All mammals are going to have a mass, which they need to pass up to the superclass. And I can kind of leave it as this. We could choose to add on additional methods, ones that pertain to mammals, but not necessarily all animals, right? Additional methods pertaining to mammals, but not all animals. That kind of thing would go here, right? So in order to correctly get dog into this class hierarchy, I'm going to change what dog is extending. Dog now extends mammal. Now everything's happy, everything's hunky-dory, but if we did not have a move method, it's going to get mad at me. Because think about this. Animal has an abstract move method, no body, right? Animal says, I have no idea what I can put here. There's nothing I'd put here that makes sense. I'm going to leave it up to my subclasses to provide an implementation. Well, here a subclass comes in. Mammal says, I don't have a good implementation for move either. I'm going to leave it up to my subclasses in order to do this. And the way that mammal is able to accomplish this is it becomes abstract. Notice that we're not even referencing move. So that move method is still untouched. It is still abstract by the time it reaches dog. And dog is faced with the same options. Either give move an implementation or become abstract yourself. Now, dogs are things I'm going to end up creating in my program. So that makes sense. It makes sense that it is a concrete class. It is not abstract. It has no abstract methods. But in order to do that, we got to go with the other option, which is implement the move method. That is what this slide is saying. Any class that extends an abstract class must override the abstract methods, plural, defined in the superclass, or be declared abstract as well. Notice that this really came all the way from animal, and it kind of got passed down, right? It got inherited down. Technically, mammal is inheriting it, right? If I come into my driver, I could create a mammal and say that it's a new dog, for instance. We need like a mass. We have a mass of 1, 2, 3, a breed of 1, 2, 3, and a fur color of 1, 2, 3. I know my examples are the best. Notice IntelliJ is not mad at me, right? This is a data type. I can create a mammal. Notice what our mammal can call. What is the compile time data type of mammal? It's mammal. The compile time data type dictates what I can call. The runtime data type is dog, so whenever I actually do call it. So the compile time data type dictates what I can call. We can call a move method because animal had it, had a signature. Mammal is going to inherit it. Mammal's not going to override it. It's not going to give it a body. It's going to pass that responsibility along, but it at least inherited the signature. That's important because that's what's allowing me to call the move method without having to do any casting conversion. Maybe you end up making an array list of mammals and you want to just add mammals to it, dogs and whales and cats. I have increased the number of mammals by 50%. Okay, so that is what our slide is saying. Let's add AVs to this. So I'm going to come in, right click, make a new class. And in order to add it to my class hierarchy, using the wrong arrow here, I'm going to extend animal. It's mad at me. I got two options. Either give the move method an implementation, that is the one and only abstract method, or become abstract. We're going to become abstract here, right? There's not a good move method I want to put here. I'm theorizing some stuff. Okay. The only reason it's mad at me now is the constructor business, so I can alt insert a constructor and speed up that process. Boom, everything's happy. I'm going to change what bird is extending. Bird is going to extend AVs. And there we have it. Again, this creates a subcategory. I could, in theory, use it to create a variable. I could save a bird in, right? I'm just going to copy and paste this one because that's a data type, right? Bird is an instance of AVs. So we can do that. What I can't do is come in with dog, right? Is dog equal to or beneath AVs in the class hierarchy? No, right? So there is a common ancestor between dog and bird. It's animal. If I wanted these two to interact together, I could put them into an animal array list. But maybe I just want mammals. Maybe I just want birds, right? AVs. This is super cool, right? This makes so much logical sense in the idea that object-oriented programming is trying to mimic the real world, and abstract classes really help us with that, create these categories that we can lump like things together, like objects together. All right, I want to hit on one thing that our slides were talking about. Lastly, and certainly not least, you can't construct instances of an abstract class. What are we talking about? I was saying that I don't want an animal, and I mentioned that you actually can't. I'm going to clean this up by, deleting it. Here's what the slide is saying. You can't construct instances of an abstract class. All right, I'm going to create an animal, and it is going to be a new animal. In order to create an animal, I need a mass. How about 7? Bruh. Animal is abstract and cannot be instantiated. I cannot make an instance of animal because it is abstract. Okay, now this should logically make sense. It should be somewhat intuitive. What is an animal? This is like so generic. It is not something that would actually exist in my program. But let me tell you why you can't do this. Why syntactically, in the realm of Java, this makes sense. If I come in here and say animal, okay, the compile time data type is animal. So I can call animal methods. That includes the stuff we inherit from object. It includes, super importantly, the move method. Boom. I can call the move method. Notice this isn't mad at me. The compile time data type of animal is animal. Animal has a move signature right there. So I can call it. Okay? But think about this. What would happen at runtime if you could actually do this? What is the runtime data type of my variable? It's animal, right? The data type of the object is animal. Okay, so whenever this would actually be executed at runtime, we would try to execute this. It's an abstract method. It doesn't have a body. It has less than a body. It doesn't even have a body, right? So syntactically, it doesn't make sense to allow this to happen. This is why you cannot create an instance of an abstract class. logically, it's not intuitive, right? Animal is a category more than is anything else. The same thing is going to be true about mammal, right? If I create a mammal, ignore what IntelliJ is trying to do there, please. I can't create mammal. Why? It's abstract. It's more of a category than anything else. And if I did, it would try to call mammal's move method, which is just the one that's inherited from animal anyway. Okay, so this is why syntactically you can't do this. That's what's happening here. Okay, so on that note, a while back, when we first made animal, I talked about how you can have a mix of concrete and abstract elements. And we saw that the moment that we plugged in an abstract method, the class had to become abstract, right? If I come in here and I get rid of the abstract class, okay, this is mad at me. Why? Animal must either be declared abstract or implement abstract method move in animal, right? Because this abstract method is here, I have to declare this as abstract. The other option would be not having the method at all, right? Then we're a concrete class. But one thing in our last video that I said that we can do is declare a class as abstract without an abstract method. Okay, why would you want to do this? Why would you want to declare a class as abstract yet have no abstract method, right? I'll delete this if this makes you happy. This is just like any other class, right? Instance variables, that's a concrete element. We have a constructor, that's a concrete element. I have a concrete method. This is just a normal class that we've been making the entire time. But why would you declare it as abstract? Because of what I just talked about. If I create an animal, or if I try to create an animal, I can't do it. Animal is abstract and cannot be instantiated. This works because maybe this is a functionality that you want. Maybe you want to keep other people, client classes, from creating instances of your object for whatever reason, right? In our case, it logically makes sense, right? Animal is a category. I don't want you to make an animal object. It's going to break the whole concept. So you can declare a class as abstract even though it doesn't have any abstract stuff if you want to keep people from making instances of your class. That's actually super cool to me. I will say that that technique probably isn't used a whole bunch in practice. Right? If we're going to be abstract, we're probably going to be abstract. We're probably going to have an abstract method. And what this does is it forces subclass to either become abstract themselves or override the abstract method. Most importantly, it gives us a common ancestor and a method signature so that our compile time data type can call the things. Okay. Let's hit our recap. Oh, no. So we can't construct an instance of an abstract class, but here's what this is saying, right? I can make a dog, I can make a cat, assuming that dog and cat are ultimately instances of animal. Obviously, I can't do this because animal is abstract. That's what we just talked about. In several ways, it makes sense. Why would anyone ever want to make an animal object? Animal is more of a category of objects than an actual object, but ultimately Java forbids clients from making instances of abstract classes because those classes define abstract methods that literally have no body. So, why does the abstract class have a constructor? Bruh, if I can't make an animal, I keep trying to autocomplete, and IntelliJ is on a different path than me. I can't do this. And yet, there's a constructor sitting right here. Why? Why have a constructor? If I can't make an animal, why have a constructor? Never forget the whole purpose of the constructor is to set the initial state of the object by initializing the instance variables. That's what our animal constructor is doing, right? It is initializing mass. Yet, I'm never able to actually create an animal object. But the thing is, this is not where I ultimately call the constructor, the animal constructor. Where does the animal constructor get called? Kind of here. And kind of here. Right? Dog is going to call its superclass, which is mammal, which is going to call its superclass constructor, which is animal. Right? Here I have this private instance variable. The only class that can see this is animal. So whenever dog needs to initialize its mass, it can't do it. It's going to pass it up the hierarchy. Mammal can't do it, right? Mammal also doesn't have access to mass because it is private inside animal. So we call the superclass constructor and we let animal do the initializing because it can actually see mass. That's why these things have constructors. That's why the abstract class ultimately has a constructor, because it needs to initialize instance variables. Even if we never actually make an instance of it, the subclasses got to get to those instance variables somehow. So an abstract class can still define instance variables. If those instance variables are private, the only way a subclass can initialize it is by calling the superclass constructor, passing it up the class hierarchy. So let's recap. A method has an implementation, is known as a blank method. What we're looking for is concrete. This is just academic language we're bringing in. True or false, an abstract class must define at least one abstract method. If you declare a class as abstract, true or false, that class has to write one or more abstract methods. This is false, right? I showed you that you can make a class abstract and just be filled with concrete things. The reason you want to do that is to keep people from making instances of your little category class. If a class extends an abstract class, that class must either be abstract or provide implementation to all abstract methods. This is so wordy. It must be a copy and paste, and it must be true. Yeah, whenever we extend an abstract class, we got two options. Either provide implementation to all of the abstract methods or become abstract yourself. Even if you mix and match, right? Even if you decide to implement one of the methods and maybe not the other, you're going to have to become abstract. The moment, if you have an abstract method, you got to be abstract. All right, consider these following declarations. We have an abstract class called vehicle. Car extends it. Truck extends vehicle as well. All right, so I got vehicle, I got car. Sorry, let me get on screen. I got vehicle, I got car, and I got truck. And they both are pointing at vehicle. Which of the following construction statements is invalid? Bruh. You can't make a vehicle. The thing is abstract, right? This would be an invalid statement because vehicle is abstract. We did it. That's it. I'll see you in the next one.